Tilting. Consider the situation in the diagram below. So here we have a plank, or I'll probably refer to it as a rod. And let's say that it's AB, so this end is A and this end is B, and that it's 6 meters long. The mass is 40 kilograms, and therefore the weight is 40 G newtons. And it's uniform, so the weight is acting at the midpoint of the rod. Let's say it lies on two supports, like so, and the reaction force on this one, we will say is R1, so that's the support pushing back up on the rod. And let's call this one R2. And let's say that those supports are 1 meter from each end. So at the moment, this is a completely symmetrical situation. So what we can say is that R1, this reaction, and R2 is equal to 40 G. So forces up are equal to forces down. If we take moments about A, then R2, the 40 G, and R1 will all have a moment or turning effect about this end. And remember, that's equal to force times distance. So the ones turning us this way, anti-clockwise, are R2 and R1. R2 times 1, so that's force times distance from A, plus R1 times 5, so this force times the distance from A, must be equal to 40G times 3. Remember, that one's turning us clockwise, so they're balanced. The anti-clockwise moments are equal to the clockwise moments. Now, tidying that gives us R2 plus 5R1 is 120G. And so 40G, take away R1, which we get from here, that's what R2 is equal to, plus 5R1 is equal to 120G. So we're just substituting this into here. Tidying that gives us 4R1 is 80G, and therefore R1 is 20G. It follows that R2 is 20G, and we said that this was completely symmetrical, so that's no surprise. R2 and R1 are both equal to 20G. So we could have got this from the symmetry, but we just went through the math because we're going to need that in a moment anyway. Now suppose we start to pull down on the end B. So we've got some force here pulling down. Clearly, if we pull down hard enough, the rod will tilt and leave the support A. So this end will go down, this end will go up. It will still be resting on this support, but this one it will not be resting on anymore. It will go up in the air. So here's the diagram again. R1 plus R2 is 40G plus F. So once again, forces up equal forces down. If we now take moments about A, it's the same as it was before, except we've got the F times 6, which is on the clockwise side. It's turning us the same way as the weight. So R2 plus 5R1 is equal to 120G plus 6F. Suppose that F is equal to 10G. Then the first equation becomes R1 plus R2 is 50G, and this equation becomes R2 plus 5R1 is 180G. So from here, R2 is 50G minus R1, and we'll substitute that in here. So 50G minus R1 plus 5R1 is 180G. That gives me 4R1 is equal to 130G. And And so R1 now is 32.5 G. And then substituting back in, that gives us R2 is 17.5 G. So pulling down here has reduced the reaction at this end and increased the reaction at this end. The total of the two reactions, of course, is larger now because of F. So the support near B now has a greater reaction force, and certainly a greater reaction force than the one near A. The support at A, of course, has a reduced reaction force. Let's increase F again to say 40G. Then this first equation becomes R1 plus R2 is 80G. And the second equation becomes R2 plus 5R1 is 360G. Remember, 6 times F, and we've said that F was 40G. Going through the same process, so rearranging this one, and then substituting in gives us 4R1 is 280G. So R1 now is 70G. And if we calculate R2, it's 10G. So the total is greater, of course, because we're now pulling down harder. But R2 is much smaller than R1. There's much more of a reaction here, which means we're pulling down harder on this support than we are on this one. As F increases, the reaction on the support near B is increasing, and the reaction on the support near A is decreasing. Let's increase F again to say 80G. The first equation will be R1 plus R2 is 120G, and the second one is R2 plus 5R1 is 600G. So, rearranging this one and substituting into here now gives us 120G minus R1 plus 5R1 is 600G. So 4R1 is 480G, which gives us that R1 is 120G. So from here we can now see that R2 would be equal to 0. So at this time there is no reaction force on the support near A, and that means that we're not pushing down on this, because otherwise it would be pushing back up. This is when the rod is on the point of tilting, i.e. of lifting off from the support. So that is how we decide when a rod is about to tilt, when the reaction force at a support is 0.